It's now been 120 minutes or 2 hours since we've taken the last hydrometer reading and ceased to suspend the soil particles. In this time period, the silt-sized particles will have settled out. As we examine the cylinder, this particular soil shows a very distinct layer of sand on the bottom and a very little, if any, layering above that. So what this is telling me, even before I go to the hydrometer to determine what amount of additional settling I've had, is that this soil is most likely primarily sand and or clay-sized particles with not a large amount of silt occurring in this particular soil. So that would be my observation just on a visual examination of this particular settling of this soil. Now what I'm going to do initially here is to take the temperature again to see if that's changed, because temperature, of course, is a variable that we have to adjust for with our correction formula on the last page of our lab handout. So I'm going to place the thermometer into the suspension. I'll hold it there for a period of time, and then I'll read what the temperature of the suspension is. I would not expect it to have changed very much, since I indicated earlier that this particular sample, this distilled water being used here, was at room temperature for a period of time, so we would not expect large changes in the temperature of the suspension, even though it has set here on the lab bench for 2 hours. And as I expected, the temperature has not changed, so it's still 23 degrees centigrade. So we'd record the 23 degrees centigrade for the temperature reading at the 120-minute mark on our data sheet in the lab. So all of this information that I've been referring to is on the next to the last page in the lab, which is entitled Data Sheet. We started with 50 grams of soil. We've taken 3 40-second readings. We're averaging those. We've taken the temperature and we're adjusting for that. That would be your corrected reading. And now we're going to we've taken a second temperature reading at 120 minutes, which didn't change, it stayed the same, 23 degrees centigrade. And now what we're going to basically be doing is to insert the hydrometer again and take our 120-minute suspension reading. We basically let the hydrometer stop or stabilize. It's basically reading the bottom of the meniscus around the hydrometer is basically reading right at 4. So what this is telling us is that there are still 4 grams of soil remaining suspended in the cylinder at this point in time. So on your data sheet where it says 120-minute hydrometer reading, we would simply write in 4, the reading we got from the hydrometer. We would go to our temperature correction formula, since it's 23 degrees centigrade. Now when we look at the temperature correction formula on page 16 of the lab, or the last page of the lab handout, what we find is that this corrected formula is telling us to take the temperature that we are at in the soil suspension, subtract 20 degrees centigrade from that. In this case, 23 minus 20 is 3 degrees. And then we are adding 0.36 to the value that we had from the hydrometer reading for each degree centigrade we're away from 20. So in this case, we're 3 degrees above 20 degrees centigrade. We're taking 3 times the 0.36 for a total of 1.08. So we're adding the 1.08 to whatever our hydrometer reading was, and that will be our corrected reading. Now, this was a little bit deceptive, because in looking at the sedimentation here at the bottom, it appeared that we had quite a lot of sand, not very much silt, and expected there to be quite a bit of clay in this soil, but in essence, the difference between the 40-second reading and the 120-minute reading is basically the content of silt. And without actually doing the calculations that are on page 16, which I'm going to be asking you to do that, I would like you to take the data that we've generated in this lab from this soil sample on page 15. I would like you to take that, plug it into the formulas, and generate the percent of sand, the percent of silt, and the percent of clay. Once you've calculated that based on the formulas on the last page of this lab handout, I would then like you to go to the soil textural triangle, which we've discussed in class before. Go to the textural triangle, find the percentages of sand, silt, and clay. You only need 2 of these, any 2. See where those 2 lines intersect in our textural triangle, and with that information, determine the textural class name. So this is the part of the exercise I'd like you to complete, and then this is part 1 of a 2-part lab. The next lab will be on the bulk density, particle density, and porosity of the soils. So we'll be working up that data in the next lab, and then answering questions on the back of that lab. These 2 labs go together as one laboratory assignment. So we'll complete the data for today, and then this lab will be included with the next lab on density, particle and bulk density, and soil porosity to complete this lab exercise.